do this one, page 12 একটা question করব আমি এখন so এটা করার পর আমি বলি কি করব এখন I'll be doing a question I'll be doing an experiment so this is the only chapter there are two actually this one and another one there are two chapters where you have experiments in paper 2 normal experiment design করে লিখতে হবে okay so এখানে একটা আছে the finding the young modulus of a wire experiment ওইটা আছে করব এই টাইপের question plenty in your past paper it can be an MCQ it can be structured question as well structured hole 3 marks MCQ hole is usually like easy ratios there so it's like 1 mark right and এটা করার পরে if we have time I'll just show you the combination of scripts and I know যে nice syllabus but for sure হচ্ছে past paper থেকে যখন question দিবে এবার একটা দুইটা চলে আসে all the time because they used to be very popular in the previous syllabus okay so anyways question একটু দেখো কি হচ্ছে এখানে and try to solve this so you have this wire here called wire A and a wire এর মধ্যে diameter হচ্ছে D and we apply a force F and because of that there's like an extension here so I'll repeat kori this wire whose length is L diameter D is given a force F and it undergoes extension you need to figure out what would the extension of this wire be which is made of the same material but its diameter is much bigger length is much smaller and you're applying 4 times the force so eta kottuku extend kore ber korte hobe you need to find your answer in terms of E মানে original যে E value ছিল ওইটার terms answer টা বের করতে হবে so দেখো তো পারো নাকি
Extension E by 3.
E by 3 the new extension E by 3 possible I know that that's supposed to be less than E but yeah E by 3 possible করে দেখতেছি দাঁড়া UA3. So what we need to do here, and where we apply what we saw earlier, the question of young models. Okay, so young models are formulated to that choice so young models is E equals to sigma, which is your stress divided by your strain, that's epsilon. Now I found that students usually struggle remembering this. So you can just write it in words, okay? So young models E is equal to stress by strain, right? So what's the formula for stress? Force by area, so force by area. Even the exam, you did write down the definition of stress, right? You can't say force by area. What you say? Definition of stress. So what is the definition of stress? That's a formula, but sorry, that's young modulus. So what's the definition of stress? Formula likely cholbe, but that length by extension, some extension by length hobe, and that's strain. Sorry. No. Yeah, cross section area bolte hai. It's the cross section of the wire. Okay, area to onek kichu hote pare. Cross section hote pare, surface area hote pare, contact area hote pare, right? So cross sectional area. Anyways, force by area into what is or divide by what is extension or sorry strain. It is extension by what length? Yes, original length. Okay, so you have to acknowledge what they mean. So right, that's basically what your extension or young modulus is. So young modulus hoche f by a and L by e. However, আমাদের এখানে e বের করতে হবে. So what we do is we make e the subject. Okay, so therefore কি আসে এটা এখানে যদি e subject করা হয়, it's f by a into L by e. And now যেটা করবো, look at this very carefully. Okay, if you have trouble solving these kind of questions, see what we do here. So what we do here is it's f by a L by e, right? এখন আমরা যেটা করব, we will do the same here, same values গুলো use করব, but we'll use it for the next wire. So the extension is equal to, what is the force for the new wire? 4F, right? And what is the cross-sectional area? So এখানে একটু problem আছে. We don't really have cross-sectional area. What we have rather? Diameter, right? So আমাদের ফর্মুলাটা নিয়ে আসতে হবে। So এটার ফর্মুলাটা হওয়ার কথা ছিল, যদি আর একটু further simplify করি, F by, what's the formula for cross-sectional area? Pi r square, আমরা r জানি না, so কি হবে? Yeah, pi d by 2 whole square, so এটা আসে, and I hope you remember we did this plenty কোথায়? Uncertainty chapter, and we found that eventually a 4 pi এরকম কিছু matter করে না. What was that mattered? D square, right? Anyways, just দেখে রাখতেছি তোমাদেরকে. So 4 F L by pi D square E. Do you agree that this is the right simplified version? 4টা reciprocal হয়ে উপরে চলে যাবে, right? আচ্ছা, anyways, এখানে 4F হবে আর আমার নিচে কি হবে? নিচে হবে pi d 2d to it, right? So this is going to be what? 4d square by 4, right? আমি যে এই ফরম্যাটটা ইউজ করতেছি, into length কত? L by 3 divided by what should the young modulus be? Same, okay? Young modulus কিন্তু for a material is always the same regardless of the shape and the size, right? এখন যেটা করতে হবে is a place where students struggle with it, which is they don't know what to do here and they keep simplifying. So cut the force and everything, right? মানে যে এই 4 গুলো কেটে ফেলবে, এরকম অনেক কিছু করে ফেলে. Don't do that. আমাদের aimটা হচ্ছে to bring which expression back here? That এই এক্সপ্রেশনটাকে ফেরত আনতে হবে, because this expression represents what? Extension. So আমি যদি এক্সপ্রেশনটাকে নিয়ে আসতে পারি, wouldn't that be extension, right? So how do I bring that expression? So এখানে যদি দেখো 4F divided by pi 4 থেকে বাইরে নিয়ে গেলাম d square by 4 times L by 3 টা বাইরে নিয়ে আসলাম, so it's 1 by 3. তোমরা যেভাবে সিম্পলিফাই করতে চাও তোমাদের ব্যাপার, I'm just trying to do it the most basic possible way. So once I do that, you'll find that this 4 and this 4 cancels out if I want to match the original value, তাহলে এখানে কি আসে 4 মানে যে আমি এটা ম্যাচ করতে যাচ্ছি ওকে সো আমার কি আসে 4f divided by pi d square times L by E, and what's the coefficient outside? 1 by 3. Now, can you tell me what is this expression here? 4f by pi d square L by E? E, right? So therefore, it's E by 3. Clear? Now, do you have to do it this way? Not at all. In fact, it's MCQ আসে MCQ তে এত opportunity থাকবে না. I'm right now trying to give you an idea of how to do the math like properly, right? So MCQ তে কি করতে হবে আমি বলি তোমাদেরকে. So তোমাদেরকে MCQ তে minimum এই এক্সপ্রেশনটা আনতে হবে this one, okay? So or yeah, এইটাই করি আমরা. So how are you supposed to do this in a minute? Because that's the time you have for an MCQ, right? So C কি করব আমি এখন এটা কি mental math করতে হবে. So my extension is directly proportional to what? Force. Is directly proportional to what? Length. And it's inversely proportional to what? Cross-sectional area, right? So আমার যদি এখানে force নতুন ওয়ারের জন্য force কত টাইমস বেশি? 4 times. So যদি force 4 times বাড়ে, what would my extension be right now? 4e. Do you agree? মানে if my force increases 4 times, wouldn't the extension increase 4 times? আচ্ছা done. Length কি বাড়ে না কমে? Kome, right? So how many times did my length decrease? 3 times. তাহলে আমার extension আবার 3 times কমে যাবে. Do you agree? So এটা 4e by 3 হওয়ার কথা right now. Then the area, this part is the one that you have to be a little careful about. The area doesn't double here, the diameter doubles. And you guys should know that if the diameter doubles, the area quadruples, right? So our area কিন্তু 4 times বাড়তেছে, which means because they're inversely proportional, extension কত times কমবে? 4 times কমবে. So our extension আবার 4 times কমে যাচ্ছে. So once I simplify this, what do I have? E by 3. Do you get the point? So that's actually the intended way. আমি এটা can করি because students একটা point আমি যে look at my work here. I didn't really do anything here, right? So যখন পরে হচ্ছে they try to solve the question, they have no clue কি হচ্ছে. That's why I give you the other way out. But I feel like once you keep doing questions like more and more, you'll figure out যে at least পড়া লাগে না. Just ratio use করবা. Also, there's a bigger benefit of learning this idea. We have a chapter in electricity called resistance resistivity. It's basically resistance and resistivity relationship. So তোমাদের O level se partly chilo. Do you remember the formula R equals to rho L by A, or R is directly proportional to length inversely proportional to cross sectional area? ওইটাতে same জিনিস আসে. You have your wire dimensions are changing. Because of that, what changes? Resistance. তখন জিজ্ঞেস করবে find the change in resistance. এই same mechanism use করতে হয়. So এটা দুইটা জায়গায় আসে on this syllabus. একটা materials আসে, আর electricity আসে. So if you understand this well enough, you will have easier time there. Okay, so just a concept that they carry. And we already saw this before as well in the uncertainty chapter. A ratio but we saw the breakdown. Okay, so yeah, that is an example. Eta hocche E by 3 হবে answer. Now, if you have your way of doing the question and you get your answer, do it. Problem nahi. Ratios is not like a fixed way of doing. There are many ways students find comfortable, right? So তোমাদের ইচ্ছা যেটা করতে চাও. আচ্ছা, let's move on. আমি যেটা করব আমি বললাম তো যে I want to speed up things here. So তোমাদের যে স্প্রিং কম্বিনেশনটা আছে ওখানে একটা পার্ট আছে যেটা তোমরা না জানলে একদমই পারবে না। সো আমি ওটা দিয়ে রাখতেছি এখন। That is this. It's a derivation. আচ্ছা, আমি derivation and example সহ দিয়ে দিচ্ছি। এটা Excel for example is part of their syllabus. But তোমাদের যেহেতু এখন নাই at this moment, I want to go into things that are actually there. যদি আজকে টাইম বাকি থাকে তাহলে ওগুলো আবার পড়াবো। So এটা হচ্ছে আমি একটা পেজে দিয়ে রাখতেছি, আজকে আপলোড করে দিব। Just have a look. এটা হচ্ছে combination of springs here. So কি হচ্ছে এখানে just বলে রাখি, I want you to understand this as well. Just একটা জিনিস মনে রাখবা, when your springs are combined in series combination হচ্ছে যেটা, right? The total spring constant is given by this formula. And when springs are combined like that, the total spring constant is provided by that formula. So have you done this derivation? Other deformation as not derived it, but you saw this formula. Achha, okay. Yeah, similar to resistance, but it's opposite. So resistance parallel hole inverse ratio হয়, এখানে parallel hole হচ্ছে direct ratio, right? That's the only difference. Okay, so I'll keep it here. আমরা যখন question paper করবো definitely করতে হবে, but at this moment I don't think there's an urgent need for it because it's really not part of our syllabus. Okay. Okay, so আমি যেটা actually useful এটা করাই ওইটা হচ্ছে তোমাদের করে আসছি আগে, but এটা একটু continuation লাগবে. Can you go to page number 17? This is very popular. Page 17. Master মানে কি exam শেষ physics next week? You have how much of waves? All of it. So আমি কিছু words বলবো, see if you're familiar. Polarization, তারপর Doppler effect, তারপর হচ্ছে double slit Young's interference experiment.
School even reach the full waves chapter, but it's in the exam.
Fascinating. হ্যাঁ, তোমাদের শুনছিলাম, তোমাদের তো খালি ওয়েভ প্রপার্টিজ আছে, রাইট? Doppler effect. আচ্ছা, বুঝছি। আর যাদের এই স্যাটারডেতে এক্সাম, তোমাদের কি সিলেবাস খালি ওয়েভস? That is like 5% মতন. That's not been done. It shouldn't be a problem. বাকিগুলো তো আছে, right? So everything that we have done, no deformation, you said.
No, we do have.
Oh, so deformation. So everything plus waves. That's okay. বাকিগুলো ভালো করে পড়ো, you should do fine. Waves now the tension করো না। Huh? No. I mean topics. If it was just waves, actually it would be worrying. But if you have like 15 chapters with waves in it, I think less than 10%. Waves was done in one class. Achha, very good. Let me explain this. এটা হচ্ছে MCQ তে very popular structure. I have not seen it recently, but it used to be there. So shall I screen it too? Can you tell me, does this material obey Hooke's law? No. Not really. Very briefly, maybe যদি বলো তাও হচ্ছে না কিন্তু it's curved. Okay. So does it obey Hooke's law? No. Why not? Because force and extension are not directly proportional, right? However, here's something. It is elastic throughout. So a point হচ্ছে it's the elastic limit of this material. When the material is elastic throughout. I have discussed slightly about this before when I showed this graph to you. I remember. What is this graph of? Yeah, rubber band. Okay, so rubber band graph এটা. এখন here's my question. দেখো যেটা হচ্ছে thing that's going to be investigated right now. So you have your elastic limit there, which means the material is not going to permanently deform, right? So rubber band যা হয়, if you take a piece of rubber band and if you stretch it and you remove the force, doesn't it come back again, right? So your rubber band নিলাম, আমার প্রথমে থেকে কিন্তু is very tight, it doesn't move, and then it gets easier, and then it gets almost impossible. You can see in the graph. প্রথমে কিন্তু অনেক steep, তারপর খুব easy, তারপর আর যায় না, তারপর আবার steep, and the steepness of the graph represents what? Stiffness, মানে how opposing the forces are, right? So এখানে it's going back again. So it means what is it always maintaining? Elasticity, right? But it's not obeying Hooke's law. So I can't reliably say যে এটা 1 centimeter যদি stretch হয়, 1 Newton যদি হয়, 2 centimeter not necessarily 2 meters. Like, you know, it doesn't 2 Newton represent per. It's not directly proportional, simply put, right? Now, one thing that we know though is that whenever you have graphs like this, the area of a force versus extension graph gives you what? Yes. What type of energy? Yeah, so a graph area under the graph gives you elastic potential energy or elastic strain energy. We have done this, remember? It's a last page today. Do you recall this class? Right? So isn't the area under the graph representing the elastic potential energy stored, right? So it was same. It doesn't matter what material it is. Graphs are graphs. So this area under the graph that you see here, right? Basically represents the total energy that you have given to the system, right? What would the label of this energy be? কেউ আমাকে একটু লেবেলটা বলতে পারবো? If I had to label the yellow area, right, what would I say? Yeah, বলো। এটা কিন্তু লোডিং গ্রাফ। লোডিং গ্রাফ মনে আছে কি মিন করে? This is like when I'm applying force to stretch my material. So loading graph এরকম দেখতে। So what does this area represent? Define the area for me. Yeah, বলছিলাম। Elastic? Correct. Elastic strain energy, fine. I mean, you're not wrong, but the correct definition would be the total energy stored in the rubber band when it is deformed. And it's stored as what? Elastic potential energy. I mean, this yellow part shows the amount of energy I've stored here right now. Clear? এখন, if you remember the spring, right, Springer graph, the loading and the unloading graphs were what? Same. So whatever energy you stored was exactly the amount of energy given back to you. When I say we did this, right? Our দেখাচ্ছি, you guys look baffled. মানে আমি কোনো রকম complicated কিছু বলতেছি না, and it's something I've done before. এই যে এই গ্রাফটা, the graph on the right, এই যে the loading graph is this area, and that's the total energy stored, right? And যখন এটা হচ্ছে elastic limiter ভিতরে থাকে, I remove the force, doesn't it go back again the same way? So am I not getting back all the energy I'd given it? Because what has not happened? Very good. No permanent deformation. কারণ deformation হলে কিন্তু energy চলে যায় আর ফেরত আসে না, right? যেটা এই যে নিচে হচ্ছে, নিচে you can see that আমি দিচ্ছি এত, I'm giving all that energy, but আমি কিন্তু ফেরত পাচ্ছি just the orange part. So isn't the other part gone, right? আচ্ছা, so same idea তে আমরা এখানে যদি আসি, এই materialটা, the one that I've shown here is a rubber band. It doesn't undergo what deformation? Plastic deformation or permanent deformation হয় না। যদি করার চেষ্টা করো কি হবে? ছিঁড়ে যাবে, right? But once I remove my force, something very interesting happens. The material, right, doesn't go back the same way. মানে যেভাবে দেখছো না প্যাকটা, ওইটা সেম যায় না। ও যায়, ফেরত চলে যায় to zero, but the path taken looks something like this. Okay? So এটা basically এই তোমার এদিক থেকে গিয়ে এভাবে চলে যাচ্ছে। So this represents the graph of unloading. Okay? Yeah, this represents the graph of unloading. So unloading মানে কি? What am I doing? When it says that this is the graph of unloading, right? What does it mean? Yeah, we are removing the force. My deformation is a force, so and the area under the unloading graph, right, tells you what? Very good. The energy you got back. So I'm going to take a stretch for it, right? Like that. And if I release it right now, will it stay here? No, right? It'll go back. Will it go back? Like, you know, in what manner will it go back? With speed, or like what's the motion? Yeah, it goes back at constant speed, or does it accelerate? Accelerate, right? So there's actually work done. And what happens is the energy stored is given out as K. That's what we use, like actually slingshot use kori, eta kori, right? Like that. And if I, you know, release it, isn't that converting the EP stored into K? And if I had like a ball or something, or a paper or something, wouldn't that fly? Right? So that's the energy transfer taking place. But problem ta kothay? Problem ta hocche, if you look at the graph that we have here, the area under the graph is not what? The same as the total energy we had provided. So total energy konta chilo? The yellow, right? And the orange here represents what? The one I'm highlighting right now is the energy that I got back. Do you agree? Our problem ta hocche, the energy that I got back here is what? Not the same. And this is a bit of a problem. Why? Did my rubber band deform? No. Then why did the energy go? Because we understand that if the rubber band deforms, energy will be retained and not given back to me. But rubber band deformed and it went back to normal. I didn't do anything to it. Then where did the energy go? Surrounded? None. This one. Why? No bonds were broken. No. Yeah, but that's the energy given back to me. No, those are all fine, but those are energy that I'll get back, right? But my question is, I'm getting back initially less than what I gave. What you guys are saying is like, let's say if I had 20 joules here, I'll fire a ball, the ball will be like 15 joules, you know? The ball has like air resistance and other things that taking the energy away from the ball. The problem to kothay boli, I gave it 100 joules to store, it gives me 60 without doing anything. But I didn't do anything to it, but it just gives me less every time. Whereas like a Springer mode, if I take like a helical spring, right? If I gave it 100, right? And if I release it right now, how much will I get back? 100. কারণ কোনো permanent deformation তো হচ্ছে না, বলো? ওটা তো ডিফর্ম করলে সবকিছুকে ধরে রাখতে হবে। আর ওটার জন্য তুমি যেটা দেখতে বলতে চাচ্ছ এটা হচ্ছে যে এই এরিয়াটা, এটা আমরা ফেরত পাচ্ছি না, এটা তো উইল সলভ, এটা পাই না, বিকজ দ্যাটস দি এনার্জি টু অপোজ দি রিপালশন, রাইট? আচ্ছা, লেট মি কাট টু দ্য চেস। কি হচ্ছে বলি এখানে, this area that you see at the bottom, the orange part, is the energy that has been regained মানে আমাদেরকে ফেরত দিয়ে দিচ্ছে। and this yellow part that you see here, এই যে ভিতরে যে yellow partটা, right, this is the energy retained by your rubber band. And what does the rubber band become in the process? Warmer. বলছিলাম না তোমাদেরকে যে যদি এনার্জি ফেরত না দেয়, it gets warmer. But the question is, why is it getting warmer even though it's not permanently deformed? Warmer তো হয় if it deforms. Deform করলে কি হয়? The bonds are broken. Bondটা break করলে কি হয়? Particles গুলো উড়ে যায় and they gain what from it? K. And that K causes your material to what in the process? Heat up, right? এখানে তো সেটা হচ্ছে না. There's nothing flying around. No bonds been broken, right? Then why am I not getting all the energy back? This is a mystery. মানে originally was. Now we know what the reason is. It's called the hysteresis of a rubber band. A processor নাম, আচ্ছা, I'll give you a note on it. এটা basically কি হয় বলি, it's a feature exclusive to elastomers or hydrocarbons. So I think you have heard of hydrocarbons. Have you heard that they usually exist in long chains, right, with a central main chain and branches out there? Okay, so a rubber band is made from some kind of hydrocarbon. Definitely, it's synthetic material, right? So এটাতে যেটা হচ্ছে, there's a long chain of carbon in it, all entangled or entangled হয়ে যায়, but সাইডে কিছু bands থাকে, right? So যেটা হচ্ছে is, if I draw it, it'll be easier. This is long chain of hydrocarbon here, and a long chain of hydrocarbon সাথে there are some sub bands there like that. And the problem is that every time I stretch and unstretch the rubber band, right, what doesn't break? The main branch. So main branchটা সবসময় রয়ে যায়, but what breaks little by little every time? The sub bands. So যে এখানে যে bonds গুলো আছে ওগুলো একটু break down করে. So because of that, what happens is main chainটা is the length of the material. So is my length of the material changing? Because the main chain is not affected, right? So since the main chain is not affected, I get back the same length. But ওই যে ভিতরে কিছু bonds break হচ্ছে, and because of that কিছু energy তো চলে যাচ্ছে, and that causes the rubber band to what in the process? Heat up. So the idea is that every time you take a rubber band and you stretch and unstretch, right, so bonds break হচ্ছে. Do you think it's retaining its properties strength, or do you think it's getting weaker over time? Yes. And this is one of the reasons why bungee jumping accidents happen. So bungee jumping, you know, so you jump using a rubber band, literally. Okay. So a rubber band হচ্ছে cycle থাকে 100,000 times cycle এরকম. Every time I do that, what is happening? Some bonds are broken, some bonds are broken. At a point, কি হয়, there are too many bonds broken, and the next person who jumps from it is the person who breaks the main chain. Donkey, but it snaps. But you use the force that you thought would be fine, but it still snaps. Because every time, what does it do? Get weaker, right? A processor, you have like rubber bands lose their strength over time. You'll find elastic bands second in your bands wastage data, but over time কিন্তু gets loose. At the point I think it's not as elastic as before, right? It kept on like stretching on stretch over time. What did it lose? Is elasticity বলি আমরা, ওটা কি size change হচ্ছে না, so কি হচ্ছে ভিতরে ছোট ছোট bond হয়ে যাচ্ছে, so it loses that elasticity. You get my point, right? Yeah, exactly. Hair bands down, so yeah, hair band use করে right? বুঝছো জিনিসটা? This is called the hysteresis of rubber band. তুমি label করে দিচ্ছি কি হচ্ছে এখানে, this is the energy retained. হ্যাঁ, so গ্রাফে 4 marks জিজ্ঞেস করে যে why is the energy not equal to energy out? আরটা আসলে যে MCQ তে ABC label করে different areas different shades, তো এইটা I think তোমাদের এই sample question এই দুই তিন থাকার কথা দেখি Is the energy retained just the small yellow area? Yes. It's retained as what? Internal energy. নিচে গরম হয়ে যাচ্ছে. Okay. Yes, it's kinetic energy of the molecules, but that kinetic energy of molecules acts as what for us overall? It feels warmer. Okay. So retained as internal energy. আচ্ছা, সো এটা আপলোড করে দেবো, তোমরা এখন কপি করে না, গ্রাফটা চাইলে দেখে রাখতে পারো, বাট আমি তোমাদের দেখাতে চাই কোথায় আসছিল এটা। এই যে দিস ইজ লাইক দ্য কোয়েশ্চেন দ্যাট ইউ গেট। আমাকে দেখো তো অ্যান্সার করতে পারো নাকি, দেন আইল আন্ডারস্ট্যান্ড ইউ অ্যাকচুয়ালি আন্ডারস্টুড দিস অর নট। Force extension graph for a particular sample of rubber as its load is applied and removed is shown. What does the shaded area represent? Bolo, quick. What is the shaded area? The shaded area. চিন্তা করে বলো, 5 minutes আগে বললাম। B. Okay, how many of you think it's A, the energy transformed into heat? Nah, right? ওটা কোনটা? Yeah, the gap here, যে মাঝখানে যে গ্যাপটা, that is A. Do you understand? Right? Recoverable elastic energy stored at maximum extension. Money key. They put it in a different wording. It's basically energy that you can regain, recover, right? What's that? The area under the unloading graph, right? So that should be it. So this is the answer. বাকিগুলো দেখে নি। Work done on the sample while loading it. ওটা কোনটা হইতো? Work done on the sample while loading it. Yes, exactly. It's actually that. Our A plus B jeta, that's actually the energy that is stored while it's stretched. Okay, so আমরা কিন্তু work done করি পুরোটা, but আমরা কিন্তু হচ্ছে store করি অল্প। মনে আছে why? Which is because there's an opposition and everything. So my final question for you: work done on the sample while unloading কি হবে? Work done on the sample while unloading. What area should that be?
Same as C.
White part, same as C. Okay, so the correct answer is nothing is there for that. Do you do work to unload it? No, what do? You just remove the force and then it goes back by its own, right? So there's no work done to unload it. There's only work done to load it because you're applying a force to stretch it. এখন তুমি যদি এভাবে করো that you're releasing the force by slowly taking it up with your hand, then there's work done to unload it, which is not what we do normally. Okay. No, you're not doing the work. The system is doing the work. Acha, so it's not over. Ajke, I want to like fully wrap this part up. যদি কিছু বাকি থাকে ওটা আমরা একটা ক্লাসে করে ফেলবো, বাট একটা জিনিস আছে মাস্ট করতে হবে। এটা হচ্ছে did you guys copy this graph that we did? কোন গ্রাফটা বলতেছি? এই যে this one. Do you have this graph anywhere? আচ্ছা, এটার সাথে হবে। I mean, what I'm going to show has to be with this graph. So এই গ্রাফটা যেখানে কপি করছো এটা পাশে এটা ড্র করো। So I'm going to draw 3 materials on this axis. Listen very carefully. This is most likely to be the question if you get an MCQ in your exam from this topic. What you need to tell me is what are the properties of the material that I'll be drawing right now. Okay? So আগেতে বলে রাখলাম I'll take a few minutes extra. So এটা শেষ করে রাখতে চাই। The y-axis is what? Stress. And what is the x-axis in that case? Strain. And I'll draw three graphs right now. Tell me what are their properties? মানে কোনটা strong, কোনটা weak, এইসব জিনিসগুলো। Right, let's start. একটা হচ্ছে এটা, একটা হচ্ছে that, আরেকটা হচ্ছে that. So yeah, three materials, 18 down the syllabus are part. Okay. So question for you is, can you tell me out of the three material here, which one is the strongest? Out of the three material here, which one is the strongest? How do you know which one is the strongest? Area under the curve. UTS. Yes, correct. That's the very it's the perfect answer actually. So the answer is blue, and it's blue because blue has the highest UTS. So আমরা যখন strength check করি, আমরা কি check করি? আমরা check করি কোন গ্রাফটা y axis সব টু করে যায়. Isn't the one that can take the most stress? What would that mean? It's the strongest. Okay, so in this case, blue is the strongest material that we have. Do you understand? কেমনে করতে হয়? বলো confusion থাকলে? Can you tell me এখানে কোন মেটেরিয়ালটা হচ্ছে weakest? Yeah, the green one, right? So weakest হচ্ছে এটা because এটা সবচেয়ে কম ফোর্সে snap করে. Do you agree? আচ্ছা, can you tell me which material here is the stiffest? মানে সবচেয়ে কম stretch করে for the force applied. Red, right? So that's the stiffest material that we have here. Yes, exactly. Very good. Radiant height. Now comes the one that students struggle with. Okay, can you tell me which material here is the toughest? Toughness কি mean করে? আমি বলছিলাম একটা example যে sponge. Did I talk about the sponge, right? Or like a soles of your shoe, like you can bend it a lot till it goes back, right? That's very tough, right? So students get confused between tough and strong. Tough and strong কিন্তু synonyms না. I can have a material that's very tough, but what isn't it? Strong, right? এইখানে একটা material হইতে পারে. I can have a material that's very strong, but not what? Tough, right? So how do you know toughness? Toughness key. So toughness is the area under the graph. Achha, the material that has the greatest area is actually the toughest material out there because it can store a lot of energy before it snaps. So my question for you is, which material here is the toughest? The blue one, right? Okay, that's not the answer. Green. Why green?
Because
We don't know. Now we know.
it's stretching the most with these force.
কাছাকাছি ওকে আমি বলি কি করতে it's a common mistake আমি শিখিয়ে দিলে আশা করি ফিউচারে প্রবলেমটা হবে না we don't compare the area as a whole we compare the area for the same amount of what stress so আমি যদি একটা same amount of stress apply করি to all three material here in this line here তোমরা কি বুঝছো what I'm doing right now I'm applying the same amount of stress right which graph do you think here has the greatest area for the same amount of stress Yeah, definitely. Look at the area under the green. Green টা হচ্ছে much higher amount of energy store করে না, but blue or red টা দেখছে একদমই energy store করতেছে না, so they're not tough. However, blue material যেটা it's a metal and they're very tough for what stresses? High stresses. So if you have a low stress, right? আমি যদি এই ল্যাপটপ থেকে bend করার চেষ্টা করি, right? It doesn't because what's the stress? Very low, right? But এটাকে if you apply a proper amount of stress, you can mold this and make it into any shape you want. That's what they do, right? মানে এটাকে যে কোনো shape করা যায়. And toughness মানে হচ্ছে it can be molded into any shape without breaking. And that happens. But what stress do I need for it? High. আচ্ছা, so এটার answerটা actually unfortunately is not a black and white answer যে এইটা বা ওইটা, এটা কি situational. So when you want to compare two material, you compare for the same stress. Otherwise, so there are materials that are very tough for very large stress, and we never go to that stress. So example, would you make a helmet out of a rubber band or metal? Rubber band helmet. Interesting. So let's say you have a rubber band helmet and if you have a metal helmet, right? What's the difference? Key behavior difference of it. Rubber band helmet যেটা খুব easily bend করবে, right? But কি করবে না কোনো সময়? Break করবে না। মানে break করতে অত problem হবে না because অনেক energy store করবে and it pops back up, right? but it bends. And what's inside it? Your head, right? So yeah, that's the problem. But metal jodi thake, metal, yes, it can bend a lot, but what does it need to bend a lot? Force, right? Jeta dawa hoy na normally. That's why it's the better material. Okay. However, eventually helmets e jeta thake, it's a combination of metal on the outside and you have what inside? A soft material, which is the momentum of the impact now. Okay. Finally, before we wrap up, a red line that can describe as a word. What is the word that describes the red line? It's a material that doesn't deform at all or much before it breaks, right? So what should be? Brittle, yes. So the red line represents a brittle material. So last, before you go, what's the opposite of strong? Weak. What's the opposite of tough? Brittle.